Yes. So the problem that we are facing in stop and wait protocol, we have discussed in the previous class also, which says that sender has to wait for an acknowledgement for an infinite amount of time, which is not required, and we need to do for this thing, right? Because it make this thing basically make this protocol inefficient. Right? In networking, we are always talking about to improve the efficiency of the network, to improve the bandwidth and all. But where here, due to this particular problem, we are not utilizing the bandwidth properly, and that's why this protocol is inefficient, right? And same on the receiving end also, which also waits for data for infinite amount of time, right? And then second problem is due to the loss of acknowledgement, which allow sender to wait for infinite amount of time to get that acknowledgement from the sender. That is again a problem. These issues we have discussed in the previous class. Now we are going to the next protocol that is known as stop and wait ARQ. Right? Now this protocol is basically designed for noisy channel. Till now we are talking about noiseless channel, idle channel, in which we are saying there is no error in the frames, and whatever we are sending is received by the receiver. So one problem we have solved, that is flow control in the previous protocol, but error control is still now not acknowledged. So using ARQ, now in this for noisy channel, this first one that we are talking about, stop and wait automatic repeat request, we call it ARQ, right? So moving further, so first thing that we need to remember is that we have taken the protocol structure from stop and wait only, and in that we have added some modules. Two things we have added, event we have added, and that is first one is the sequence number. So every frame is now will be have some sequence number, and that sequence number will be with the help of modular 2 arithmetic. Modular 2 arithmetic means that we are taking binary 0 and 1. So one time the frame number will be 0, another time the frame number will be 1, and this sequence will continue 0 1 0 1. In this manner we are sending our frame, we are recognizing our frame, and we will send it to the receiver. So in stop and wait ARQ, the acknowledgement number always announce in modular 2 arithmetic the sequence number of the next frame expected. So if one frame is sent that is 0, then the next frame and the acknowledgement will be sent by the receiver will be 1. You can see the design over here, and if we compare it from the previous simple stop and wait, you will find this thing is missing, that is sequence number. Similarly, this thing is missing, that is time. So in the previous scenario we have seen that sender and receiver, they are waiting for infinite amount of time, and we have discussed that how we can solve this problem by deploying this module, this event, that is timer. Now this timer event will not let the sender or the receiver to wait for infinite amount of time. This is how we solve this problem, right? And another thing that we have added is we have added sequence number SN. This sequence number will distinguish between the frames, right? One frame that is 0, the next frame that is 1. In that sequence, the next frame will be 0. So this is how the modular 2 arithmetic is used for numbering the sequence number in the frames. The rest of the thing is same as we are doing in stop and wait. So how it works is that first of all, whatever the data we will get from the network layer, it will be converted into frames, and here frame will be given some number with the help of modular 2 arithmetic. So the first frame that we will defined, that is Sn is equal to 0, right? So here this 0 frame will be sent, right? Here this Sn frame is sent, right? Now when this frame is received by the receiver, and if there is no error and it received, then what will happen? The receiver will send acknowledgement frame as we are doing in stop and wait. But here one more thing is added, that is we will send the sequence number of acknowledgement also, and that is what the expected frame. So what is the next expected frame from the receiver? That is 1. So receiver will send that, okay, I have received the frame 0, now you send the next frame, that is 1, right? So Rn frame will be like this, that is 0 plus 1. So we have kept Rn is equal to 0. Receiving sequence number, that next expected frame is 1. So 1 will be delivered over here, and sender will get to know that the previous frame, that is 0, is received successfully. The sender will do, that is Sn is equal to now 1. Now the next frame will be, next frame in the sequence will be 1, that will be sent. Now receiver will send, if the 1 frame is received, receiver will send acknowledgement for 0, means the next frame is 0, which is receiver is waiting for, right? Now we will see the overview of this, how it is working. So we have added a event which basically talks about that if within that simulated time, if the receiver has not sent the Rn frame, then there will be a timeout. And when there will be a timeout, it means that now sender has to send the same frame again, right? Sender will not send the next frame since there is a timeout. So this scenario basically talks about how to limit the infinite time which is sender and receiver they are waiting for the data packets in the previous scenario. Yes, so we will see how it's work basically. Sender A sends a data frame with a sequence number 0. This is the first step. Yes. Then receiver B, after receiving the data frame that is 0, will send the acknowledgement with the sequence number 1. If the frame 0 is received, then the acknowledgement for next frame that is 1 will be expected and will be communicated to the sender. The sequence number of the next expected data frame or packet. There is only 1 bit sequence number. So please remember here the window size of sender and receiver is 1 again. So we are taking this thing from the previous protocol, that is the stop and wait, in which we are saying 1 frame at a time, and the same thing we are following over here. So we are sending 0, we are sending 0 frame, receiver is receiving that 0 frame and sending frame 1 acknowledgement, that send me the next frame, right? So if we check the algorithm, you will see we starts with the sequence number. Now this thing was not there in the previous protocol, so we have added over here, that is Sn. So we have initialized the window from 0 because sender is sending the first frame, that is 0. Now can send, as we have done in the previous scenario also, that it is true, right? So you can see is request to send from the network layer and can send, then get the data from the network layer make the frame and number the frame. So here we have given a sequence number. This thing was not there in the previous scenario. Now we have added. We are numbering the frames. Now please remember this thing. This 0, 1 is not your data. Here the frame which holds the data inside. This is your frame, and this frame is named as 0. This entire frame is named as 0. Here you have your data 0, 1, 0, 1, 0, 1 like this. And this frame, which compose of sequence of zeros 1, which actually holds the data, is named with sequence number 0. The entire frame is named with sequence number 0. Don't get confused with this. This is not your data. This is the sequence number of your frame. Each frame holds the data. Getting? Any doubt till now, class?
No, sir, it's clear.
Okay. So we are here in the sequence 9. So what we are saying that we have to make frame, and we are doing this thing in stop and wait and simplex method also. But what we have added over here is we have added the number to that frame, and frame holds the sequence of data, that is zeros and 1, and that each frame is now numbered with 0 modular 2 arithmetic. With the help of modular 2 arithmetic we are doing that, right? Then one more thing that we are doing, that is we are storing that frame. And why we are doing this thing? Since if there is a timeout, timeout for receiving the acknowledgement from the sender, then what will happen? There is a need of retransmission. As I told you, that packet frame 0, or you can say that frame 0, this one you can see over here graphically, this frame 0 which we have sent, if this frame does not, acknowledgement of this frame does not arrive within this time period, then there will be a timeout. Now what we have to do when there is a timeout? We have to do retransmission of the same frame. So doing retransmission of same frame, we have to store it. So that's why in sender side algorithm we are putting this thing, that store the frame till we receive the positive feedback from the receiver. So the same sequence. So what we are storing? We are storing the frame 0, where because Sn is equal to 0, right? So store frame 0, make frame 0, and then store it. We need a memory for this particular. So this is an additional part which is not there in the simplex and stop and wait protocol. Whereas in stop and wait ARQ, we are talking about error control. So that's why we are doing this thing, additional task. Then we have to send the frame. Which frame we have to send? 0 frame. The first frame, that is Sn is equal to 0. So we are sending send frame 0. Immediately after sending, what we have to do? We have to start the timer. As you can see over here in this diagram, flow diagram, immediately we send the frame, we have started our timer, the first thing that we have done. And within that time period, we are expecting the arrival of the acknowledgement. And this is how we eliminated the previous problem where sender is waiting for infinite amount of time. Now sender is not going to wait for infinite amount of time, since we have added a small timer. Please remember this thing, right? Algorithm, we say start timer, and we have incremented our next frame. So Sn is equal to 0. So now the Sn will change to, sender will know that next frame will be Sn. Sn is 0. You can see from here Sn is 0. So 0 plus 1. Now the value of Sn is increased by 1. So the next frame, the sender is waiting to send for the next frame. But sender cannot send because we have added can send is equal to false. Can send is equal to false. Now sender is waiting. So that's why it is called stop and wait. So now here sender has stopped and waiting for positive acknowledgement. Right? This is how it is working in sending side. What else? So you can see here we are having two events. This is the sending of frame and then arrival notification. So that's why in our program in sending side we have to insert this event also, that is arrival notification, where arrival notification talks about the acknowledgement number, the frame which we are going to receive from the receiver, and that will be 1, right? So if the frame is not corrupted and acknowledgement is equal to 1 is equal to SN. What is SN? In the previous scenario we have incremented to 1. So acknowledgement number, that is 1, is equal to 1. It means, right? It means we have to stop the timer. We have to purge the frame, means the previous frame which we have stored here. Now no more further needed. What it means? That now delete the frame. That the copy of previous frame which we have kept for retransmission is no more further needed since the task is successfully completed. So we will purge the frame and then can send is equal to true. So now can send is equal to true, which is false in the previous module, and sender is waiting to send SN is equal to 1. So SN frame will be sent over here now. Can send is equal to true. And immediately after that, the timer will start. Right? So this is the algorithm for doing sending side events. Right? Whereas on the receiving end, what we will do, receiving window will be initialized with 0. It means that frame 0 is expected to arrive from the first frame, that is by the sender, and it will always be true, and it is waiting for the event for arrival notification. If the data frame has arrived, receive that frame, check that frame. If the sequence number is that same that is expected, and send. So SN is equal to 0 and RN is equal to 0. It means that is a valid frame. We need to extract the data as we have did in the stop and wait and simplex method. We deliver the data to the upper layer, that is data link layer, network layer, sorry. And then we increment the value where Rn is equal to 0. So Rn is equal to Rn plus 1. So the value of Rn will be incremented and sender will send the Rn, that is 1, which is the receiver is waiting for. Yes class? Any doubt? Please be on time. Yes. So this is the sequence number by the sending side. That is the Rn frame. And Rn is how much? 1. So 1 is sent, that expecting the next frame, 0 frame is received successfully, there is no issue, send the next frame. So Rn is the sequence of the next frame that is expected. Right? Now, if you see the flow diagram, it will be more easy for you to understand. Right? So here we have taken one side, there is a sender, other side is a receiver, and we have said that we having a sequence of frame, and we have numbered each frame with the help of modular 2 arithmetic. That is 0, 1, 0, 1, 0, 1 in this sequence always. And receiver will also have the same sequence window. We call it receiving window, we call it sending window, right? Anchal Rani, be on time. Why you are late in class? Yes. So first frame, sender has sent 0, receiver received it, and increment the value of Rn from 0 to 1. So Rn is equal to now 1, and the value, this R1 is sent in this acknowledgement. That's why it is 1 over here. Acknowledgement 1 is sent. Receiver will receive it and send the next one. So Sn is equal to Sn plus 1. Now the one frame is sent, right? Since it has arrived in a stimulated time within the time period, that is the clock which we have set initially, so there is a successful transmission, and that's why Rn is also incremented by 1 and Sn is also incremented by 1, and previous frame is now deleted. The copy of previous frame is deleted. We don't need to retransmit because receiver is saying that we have received it successfully. Now this is one scenario. This is another scenario where you can see that the next frame which is expected by the receiver is 1, and if it get lost in the network. Now see, there is no timer over in the receiving end. There is no timer in the receiving end. So there is no problem for the receiver. So timer is only with the sender. Sender is believing that I have sent the frame and it is about to reach to the receiver, and receiver is checking it and then will send me the next frame, that is 0 expected frame. So I will send it. But this thing has not happened on time. Since this packet has lost, receiver has not received the frame. So how receiver will send the acknowledgement? So there will be no acknowledgement from the receiving end, and once the time get out, then what will happen? Time will be restarted and the same copied frame will be resent. So frame 1 is resent. Again you can see frame 1 is not successfully delivered and we have not get ARQ. So here what is happening? Automatic repeat request. Automatic repeat request. How it is happening? Because time is collapsed, and after that time sender will see that there is some wrong in the network. Might be receiver has not received the frame. So what I have to do is I have to send the copy which I have kept. So retransmission will occur and the same frame will be sent again. So this is how we have done the error control mechanism, right? We have done this this thing over here. So retransmission take place, and when this frame received successfully, the receiving window, so that will be a next sequence will be 0, and that is the expected frame by the sender. So acknowledgement 0 will be sent, and within that time period the acknowledgement has arrived. So Sn value get will be 0 because it is expecting from 0 frame. So next 0 frame is again sent. Now in this scenario, this is the third scenario where acknowledgement is lost in between. Then what will happen? Yes, if the acknowledgement is lost in between, then again, since we have kept timer, so sender will send after a new timer, sender will send the frame 0 again, which the copy of frame 0 which sender has kept with it will be resent, right? Now it will be received on the receiving end. But what is happening over here? Can anyone tell me? Yes, receiver has already incremented Rn. Since frame 0 has received and receiver has successfully received the data, but sender has not received the acknowledgement for 1. So sender will send the same frame 0 which is not required by the receiver. Receiver is expecting frame 1 and sender is sending frame 0. So there is a duplicate frame which will not be accepted by the receiver and it will be discarded. Since Rn is 1, Rn is not 0, and the frame which is received by the receiver is 0. You can see over here. And receiver is waiting for frame 1. So what will happen? Receiver will get to know that this is a duplicate frame. So receiver will not act on it, and receiver will discard and will send that Rn is 1. Send me the next frame, that is 1. So automatically the lost frame, the lost acknowledgement over here is now arrived in this manner. And now the sender will increment its ascent, this one, and send the next frame. Yes, any doubt till now?